All right, so a few things I want to talk about. And actually, I'm going to talk a little bit before I start getting into this slide. We're going to talk about some of the history of the symposium and the way that we're used to doing things, right? So historically speaking, the first talk of the day would usually be a state of the industry discussion. Maybe it would be a panel, or maybe it's me talking about what has happened in the various game industries, hardware industries, that kind of thing that's been going on. This year, we actually kind of decided to forego that talk because the industry itself has not fundamentally shifted that much from years past. There have been evolutions, there have been changes. There's just having a conversation this morning about like Microsoft and what is Microsoft's strategy and what can we do with Microsoft's strategy. And in just like the last couple of years, the answer to that is not totally sure. You know, they keep promising continued development and moving forward while also laying off people by large quantities, right? So it's hard to know exactly what their strategy is because they haven't published something that we can hold them accountable to. You know, the other big news, of course, is Apple entering, right? And that's been interesting. And they have a good device. And if you want to learn more about their device, please see Dr. Ari Blankhorn's talk about some of the devices that are coming out. Because she has, you know, some good discussion about comparing the devices and whatnot. But I will say from a fundamental perspective, it is a good device with perhaps a questionable value proposition for those that are in the industry who are comparing things. I don't think I'm going to cause anybody heartburn by saying that. But it doesn't fundamentally change our capabilities. It's not a completely industry shifting release out into the world, right? On the software side also, we're not seeing huge amounts of shift, you know, in terms of what the engines are. I will say that it has been a little tumultuous. We are, again, seeing layoffs across the gaming industry, some of which, again, are hotly debated as to why these layoffs may be happening. For the game engine perspective, you know, Unreal has changed their pricing model, and so that is no longer free for organizations such as ourselves. In many ways, I actually view that as a good thing because we're no longer seeing projects that are picking the engine with the lowest upfront cost, which is not a reason to pick an engine, really, right? So now we're having better discussions about capabilities of the engine and what a good fit the particular engine is for the various projects. And we're making sure that we're picking the right engine. So if you need some of those high fidelity, high dynamic, super detailed meshes that use some of Unreal's capabilities, that you're picking it for those reasons, that you're really using it for the right reasons, not just because it has a lower upfront cost. On the Unity side, there were certainly some missteps made. The former CEO is out. The less I talk about that on recordings, the better. I do think it is good and healthy overall. The other thing that has happened with that is that it has helped the Godot engine, which is an open source game engine. I'm a big fan of open source, open standards, open file standards, open networking standards. And so seeing an influx of people going to that engine, even though it may be at the expense of the engine that I am most experienced with, I actually view as a good thing. And we've recently been seeing some news about bringing some of those open standards and looking for RFPs to bring some of those open standards for XR to that open source engine, which I view as a very good sign. So those are really, you know, those are the highlights, and that took about 5 minutes. So there you go, Nick, filled in your time for you. But that's, you know, that's been the biggest news. There's been lots of other stuff, lots that's promising. It's still a healthy industry, I think. We're seeing lots of movement. We're seeing lots of adoption, especially on the commercial VR side, the gaming and entertainment side, which we knew we were going to be able to do. But that also means that we are getting hardware that is more affordable, more capable, and at very reasonable price points. So, you know, we are very far away from the world where we started, where it took, $3,000 to $5,000 to even start playing, right? When we started this about 8 years ago, that's kind of where we are. Now you can come in and for $600, you can have a really capable headset that you can do a lot of stuff with, and that you don't necessarily need a $3,000 gaming rig to be able to power it, right? So, and I don't think that's going to change at any point in time, right? We're now at millions of devices delivered. There is an established community here. There's an established revenue stream. It may change, it may shift, but I don't think we're ever going to go back to this super high-end professional is the only answer to be able to get into and playing with and working with this stuff. So again, I'm democratizing it, making it more accessible, making it more available to more people, I always see as a good thing. So there have been some changes in the industry, but not the XR industry as much. The big thing is the ancillary industries that are around the XR industry. And the biggest one, I think, the biggest shift, and we started to see this last year, we talked about it some last year, was artificial intelligence. We talked about generative AI, we talked about LLMs, and we said, hey, keep your eye on this because it is poised to change how we do things. In the last year, that has proved to probably be an understatement. It is changing a huge amount of how we look at work, how we look at our capabilities, how we are able to deliver, how we are able to do things affordably, and the audience that we're able to reach, and the capabilities that that audience are going to have. Generative AI and LLMs, I will say, especially for XR, is a game changer. We thought it was going to be true last year. This 12 months has proved it to absolutely be true. So that's why my 3 talks are going to be going on about augmented reality, virtual reality, and artificial intelligence. So I'm going to talk about why you might want them, some of the dangers, pitfalls, some of the good stuff, and then the second 2 talks are, the second talk is going to be how to embed an AI into your game engine so that you can actually use that AI in your game or experience or whatever you want to call it, right? And then the last talk is really pushing the envelope on bringing brand new kinds of interactions that were essentially unthinkable 2 years ago. Things that if you had told me I would be doing, I would have laughed and said, that's way too science fiction. So we're going to get a little wild and crazy on the third talk. Computer science wild and crazy. But it's still a lot of fun. So the first thing I'm going to do is talk about XR and AI concepts, right? Leveraging different types of AI. There's a lot going on in this space, and so I want to take an approach. Now, when I go into this approach, I'm not going to go into here's the architecture of the AI and get into dropout and other optimization techniques to get it to fit onto your hardware. That's not my specialty. That is great. There are lots of AI experts here at APL that I'm sure would love to go into that. Again, it's not just even in our team, it's across APL. We love what we do, generally speaking, and so we love talking about it and getting into it. So do strike up that conversation if you find somebody who is an expert, because they're almost always willing and thrilled to really chat with somebody about their area of passion. Okay, so this talk is going to focus on theory. Why do we as XR specialists care about AI, the types of AI that we're generally going to take, and that's going to be from a software architecture perspective, not from a AI design perspective. And then some pitfalls and cautionary tales, because a lot of this is research. And then in the following 2 talks, I'm going to go into practice, right? How do I embed the AI models into XR projects, and then using AI in an XR application at runtime to do new things. So about myself, I'm a software engineer. I've been doing software design, architecture, engineering, programming for 25 plus years. I was there when the World Wide Web was shiny and new. I was there when cell phones were shiny and new. Smartphones were shiny and new. And then, of course, here when XR and AI are shiny and new. One of the things is, a few years ago, when I was in my group prior to being part of the IT department, I had a choice between going into artificial intelligence and being an artificial intelligence expert or pursuing the augmented and virtual reality. As you may suspect, I went and specialized in augmented and virtual reality because what I found with the AI, I was interested in it, but I didn't love linear algebra that much. Backpropagation was fine, but sometimes it would drive me nuts. And I really liked using the AI more than building the AI itself, right? And so I was always putting the people in the center of my process. What can this AI do for my people? And so as such, I went and I focused on the XR side because that's the more human-centric thing, which I was more passionate about. But the AI still does hold a little happy place in my heart. Again, I learned about backpropagation in the early 2000s, back before we had the high-end amazing compute that have allowed that AI segment to become what it is today. This is kind of, this is wonderful for me because it's the Venn diagram. This is my happy place where those two circles overlap. And in the last year, a huge amount of our work at 8PL involving XR and game engines, real-time 3D, maybe not necessarily headsets, but real-time engines, has involved some aspect of AI. It is taking over our time cards, as I like to say, because our projects, it's either integrating it or working with it or providing synthetic data for it. So I'd probably say 80% or more of our work right now has AI in some way impacts that work or integrates our work with AI across our team. So why do we care about AI? Because XR experiences are fundamentally human-centric. And in fact, it is the most human-centric compute that has ever been. I know that is sometimes a hyperbolic statement, but we are actually literally, when we put somebody in a headset, we are putting the computer around their head. The human is literally the center of the computing platform. It's one of those things where, and also when we start moving into hand tracking and eye tracking and heart rate monitoring, these computers know more about their operator than any computer ever has, ever. Now, when we talk about AI, LLMs and generative AI, they're doing something that we haven't really seen before. Computers are deterministic, right? We know this. You put in input A and you get output B, and you get that very reliably. And what's interesting about how deterministic computers are, we even think about like random number generators. Turns out in computer science, random number generation is like a hard problem, right? Because computers are so dedicated to being predictable that actually getting them to do random things is very hard, right? And so we do use them, however, to help us with stochastic problems. So when we have randomness and statistics and stuff like that, the computers are able to help us work with that. And that's the underlying fundamentals of how a lot of these neural networks work, is there's a lot of statistics and, we can talk about Bayesian networks and backprop and whatnot, but fundamentally it's much more probabilistic than the procedural programming that most of us are used to today. Humans, as people, we are stochastic creatures. We live in a stochastic world. Things are random. Things are fuzzy. Things are not well determined. We try to be deterministic, especially as programmers, right? We spend a huge amounts of effort to try to think as logically as we can, and all of the bugs show my failings in my ability to do this, right? I'm a stochastic, emotional, fuzzy being, as much as we try to be deterministic. But LLMs are interesting in that we're now able to take the computer output and we're able to humanize it. One of the things that's interesting, especially as we start talking about media, but also even something as simple as a text-to-speech engine, right? The speech-to-text output gets more acceptable to the human operator as we add emotion to it. Right? Because if you think of the old school, like super robotic voice, right? That wasn't acceptable for so many things, right? But now, as it's gotten better, there's more inflection, there's more emotion, there's emphasis on specific ideas and thoughts in that. That makes it more palatable to the human operators. And so it's actually that injection of emotion that helps us humanize the output of the computer to make it more accessible and more impactful. And then also what they can do is they can computerize human input, right? And humans, you know, we're buggy emotional messes. It's okay. And so as we communicate with the computer, having a mechanism to take the not as precise as a computer really wants input and be able to organize it or classify it or structure it in a way that is more acceptable to the computer is an extraordinarily powerful tool, because up until now, people have had to think like the computer and able to work with the computer. And we've gotten better and better. It started with like, you know, just machine language, and you'd have to learn like assembly and stuff like that to really interact with the computer. And we've gotten further and further away, but even programming languages, you have to think like the computer and able to interact with the computer. And now that we have the LLMs, we actually have a mechanism that we can interact in a much more naturalistic and collaborative way. And so I am interested, a lot of my work is focused on creating collaborative and engaging and also playful interactions, because when you're not forced to think like what your collaborator has to think like, you can be more creative, you can be more playful, you can explore more ideas. And yes, I will continue to say that LLMs right now, right, sometimes their output is subpar, right? But the truth of the matter is if you have ideas and if you're exploring ideas, it allows you that exploration and that open space to be able to try things very quickly and very effectively so you can figure out what does work and what does not. So for a rapid iteration, especially at the beginning of a process, these kinds of tools are wonderful. And I think as they continue to develop, they're going to continue to be more powerful. And we have already seen advances away from, hey, this is mediocre a lot of the time, to this is mediocre some of the time. And I think that's going to continue to improve. So from a software architecture perspective, there's really three kinds of AI. This is not really any different than, you know, talking about embedding a library or something else, right? So you have the platform embedded AI. This is provided by your operating system, right? So just like Windows, Linux, Mac all have a file system that is provided to you, and there's hooks into that are provided to you. You don't have to write your own file system. You can if you don't like yourself, but you certainly don't have to. That it's built into the device that we use. It provides hooks to it, right? And so we see this, and the performance is out of our control, right? Because it's abstracted away. Somebody else has done this work for us, right? But for hand tracking, right, so all the hand pose estimation that's happening on, say, a Quest 3 or a Vision Pro, right, there is an AI that's doing that hand pose estimation. It's just abstracted far enough away from us that we only see the result, right? We don't see the input. We only see the output. And the benefit of that is that the performance of that is often like put off to specialty chips or the operating system, and that you know, turning on hand tracking shouldn't negatively impact the performance of your app on the thing, right? So that's the first type. I'm not going to talk about that too much because we don't do that, right? That's just a service that we use that's provided by the headset. The next is application embedded AI. So maybe you want to do something with AI in your application that it isn't able to do right now, right? So you're going to be running it locally on the hardware that you're using. Now, what AIs can you run locally on your hardware is going to depend really on what hardware it is that you're using, right? So you can do speech recognition. Again, some systems have built-in speech recognition, but maybe it's not good enough. You want your own. You want a more full-featured model than what comes boilerplate, right? You can actually implement speech recognition AI in your app on your headset. Real-time ray tracing, that's, again, something that your app can turn on. It dramatically increases the visual fidelity of what you're doing. That is an AI-based system. And then we also have an example of a real-time water simulation. And I think that's interesting just because it allows a new kind of interaction that before AI was essentially impossible. And then we have external AI. So this is stuff, right? An external service, it's usually running on another machine in your network, or it's running on the cloud somewhere, but essentially you are offloading that work off of your headset to something else, right? It runs off device, usually in the cloud. Some of these models are mind-blowingly powerful. You do often get high latency, so you need to account for that. And so something like ChatGPT or Stable Diffusion would be a couple of examples of where you might want to be able to do that. So this is the water simulation. So this is application embedded AI. I will have this demo this afternoon. If people want to come around and splash in water that doesn't exist. But the whole idea is that this is running on a laptop, and it is a simulation of water that is rendering at human scale frame rates. Now, normally when you do water simulation, it's extremely precise, high cost compute to be able to do water simulations. Is this water simulation perfect? No, it's a little rough. You can see that it's very coarse. And that if you look at it mathematically, it is not going to be completely precise, right? This is about using an AI as a good enough problem solver to communicate an idea and to communicate an experience. That we're able to splash around and move water around, and you'll be able to do it. It runs on a laptop. And that prior to AI, the calculations to do this were far too complex and demanding because, again, there was only that deterministic, this is the only real solution to it, as opposed to the more stochastic, faster, this is a good enough approximation of what happens that we are able to do this, and then we are able to do it very quickly so that we can run it at 90 frames a second. So this is running both the water simulation itself at 90 frames a second and also rendering to 2 eyes at 90 frames a second. So this is a very busy computer, but the fact that we're able to get this on a laptop is a very new kind of interaction. So this video has audio, and so this is the use of an external AI. In this case, I'm using Stable Diffusion to do some art generation.
All right, so for this demo, what we're doing is we are using virtual reality and Stable Diffusion together. So Stable Diffusion is a great generative AI system for art. The problem is sometimes it's difficult to describe what you want, and it might be easier to show the system what you want. So I have an environment here with a bunch of building blocks and whatnot, and so you can take these objects and you can move them around, and you can make the scene that you want. And so you got this little camera here. And you point the camera, and you compose the scene that you want to be able to demonstrate. And it's actually basing it off on that far world, and it's creating this depth map. And the depth map is what the system is going to use as an input to Stable Diffusion along with the text prompt. Now, in my case, I already have some preset text prompts here. I wanted to just have some that were handy. At some point, I want to add in speech to text so that you can create your own prompts. And for now, we're just going to go ahead with one that's in here. So we're going to click beach, and this depth map gets submitted, starts working, and the diffusion process begins. And it's going to take these objects in the scene, and it's going to try to make sense of them. So in this case, these long tower pieces are turning into pieces of driftwood, while some of these other shapes are becoming stones that are in the scene. And if we wanted to change styles or something like that, we could try another prompt, and now we're generating a cyberpunk city scene based off of the same depth maps that we gave it before.
So this is another example of a playful interface, right? So I want to be able to just take my building block. So maybe I have an idea of a scene that I want to compose, right? Instead of doing the art myself or just trying to, use DALL-E or a Midjourney, right, and type out exactly what I want, I'm able to provide an example that I have the idea, I can get that idea out, and then you can use the other tools to be able to refine it and improve it. All right, so when would you want to use what? So platform embedded systems, it runs on the device, performance is generally not going to be a hit for us, or if it is, it's a bug from the vendor. They're generally designed to be performant. Use them when you need them, or when the quality is good enough. When are you going to embed AI into your application? It runs on the device, so latency is low, right? So something like that water simulation, right? You can't have that be off device. The latency would be too big. It wouldn't feel realistic, right? It's also easier to secure. So if security is a concern to you, then you're going to want as much of your AI running on device locally so that you don't have to deal with network stuff. Performance impact to the user experience is AI and device dependent. Some of these AIs are really, really, really power hungry, right? Just because you can copy the files onto your machine, running it doesn't mean that it's going to be a good experience. So you do have to think about how the performance of the AI is going to impact the rest of your experience. So if you have the compute resources, go ahead and use it. And or if it really needs to be on device for security and networking reasons, go ahead and use it. External AI, remote compute and cloud service security is based on cybersecurity and contractual constraints. Sometimes that's easy, sometimes that's hard. That's going to depend on your project and your organization and how your organization makes deals with other organizations. I will say that process always takes longer than I think it should. But that's probably a me problem. It does require a network connection, right? You're not running it on device. Models are often extremely powerful, especially with some of the latest generation of AI that we're seeing. It doesn't impact the user-facing application performance. So this is really nice, is that application that I showed you, originally I had Stable Diffusion running locally on that machine, but the impact to the user was too significant. Their frame rate would drop. Right, it became a very poor experience while the AI was generating the art. So by moving that off to another machine, I was able to keep the frame rate up. It was still a nice, playful experience, and so the art would go generate while I was doing something else. Remote processing may introduce latency, so again, you do need to engineer that correctly. But use it when you have the sufficient network bandwidth. Latency is an issue, and you can get those agreements in place. So risks, pitfalls, cautionary tales. Things like hand tracking is very useful. Depending on the API, can tightly couple your code to a specific device. So maybe you're working on device A. We are still seeing new devices coming out all the time, right? And so you want to be careful about how you design your stuff, whether you're using Unity or Unreal or whatever. You don't want to be too tightly bound to one particular headset because there is still a lot of churn in this market, right? Use open standards, things like OpenXR, big fan of open standards, being able to have interoperability so that as devices change, the code moves from device to device more seamlessly. Now, it doesn't mean that it's going to be zero work to move it to a new device, right? You may need to do, might have new button bindings or something like that. Or if you're used to having controllers and need to move to something that no longer has controllers because it's a hand tracking only device, there's still going to be some work there. But at least you're not looking at your entire rendering pipeline and figuring out, oh my gosh, how do I even render to this device, right? So having the open standards is very, very valuable for organizations who are looking to leverage this hardware. If there isn't an open standard for what you're trying to do, some of the hand tracking devices and whatnot don't use OpenXR, then what I highly recommend you do is you write a code, an intermediate layer that's an interface to that hardware, so that it's abstracting away the details of that hardware so that if you ever need to move to another piece of hardware, that's the only code that changes, that you're not rooting through your entire code base and trying to figure out, oh my gosh, where is everything, everywhere that I use this hand tracking code, right? That you have all of the device-specific hand tracking code in one area so that you know that that's what you're going to have to re-implement if you switch hardware platforms. For application embedded AI, integration can be very consuming. It is getting better, but especially that first time, there is going to be some heads to desks as you figure out and bash your way through it. It's just not super easy yet. And again, we've talked about performance. It can have a massive performance impact on your app. So you do need to test on your target hardware. External AI, I mentioned latency as a problem, and that you need to design the user experience so that if there is a network outage or there is, a request is taking a long time, you need to be able to handle that gracefully. So there is some, network and exception coding that would probably happen there that wouldn't happen in the other types of AI. And of course, getting your proper agreements in place so that you're working with vendors that are appropriate for your project. So that is the first of 3 talks. And so we have 5 minutes for questions before we get into the next one. Good question. Yes?
Good examples you know of that are using generative AI to create interactive, where you're asking the avatar?
So the question is, are there any examples of where we're using generative AI to create an interactive interaction with the user? So certainly we've seen in the entertainment industry, there's non-player characters, right? So you have a world, you have a game, and you have a character, right? And that you are interacting with that, person that isn't this character that is not driven by a human. And yes, we are absolutely seeing those characters now being filled in with, your ChatGPTs of the world. We've seen it for a couple of years. I think only now the technology is getting to the point where it's going to be good. It's interesting because that has some interesting implications on game design. If every character has their own personality and can interact with you endlessly, do you actually want that? But certainly there are things like help chatbots and whatnot where that's certainly possible. And then we also have some research right now where we are helping somebody repair a device. And so we have an avatar that you are communicating with, going back and forth, and it is helping guide you, saying, hey, look at this network cable, look at that power switch. And then once you've done enough of that diagnostics, you can have that interaction, and it'll say, okay, here's how you repair it, and it'll go through step by step. And so, yes, we are seeing those kinds of interactions. And then in my third talk today, we'll have some different kinds of interactions that are powered by ChatGPT. Any other questions? All right.